Have you ever calculated the internal rate of return, the IRR, and maybe got two answers? Or worse, not at all. Well, it's not a calculator error, it's math telling you something important. And today we'll go down to the applied side of the issues we've been talking about previously by talking about IRR and what it really means, why it matters, and what to do when it's not unique. So what's the internal rate of return? It's that rate that makes the net present value of all your cash flows equal to zero. This is what the formula looks like. In simple terms, it's the break-even interest rate. The rate of return that makes your project's inflows exactly offset your initial investment when discounted. If your IRR is higher than your required rate of return, the project is considered acceptable. That's why investors love IRR. It gives a single number that summarizes a project's profitability. Now remember our bond pricing in lesson 2? The price of the bond is merely the net present value of the cash flows at time zero given a particular interest rate for discounting those cash flows. So in return for those positive cash flows to you in the future, you pay the price, which is now a negative number because you're paying for it. And this is what it looks like. However, this time we are searching for the interest rate for discounting given all positive and negative cash flows. The negative cash flow being the price you pay for the bond. So here we just put price at the right side of the equation, then look for I that will make NPV equal to zero, like so. In this case, the IRR is actually just the interest rate for discounting the bond to arrive at the price. So why is IRR so widely used? Because it's intuitive. It feels like an interest rate, something everyone understands. Managers and investors can quickly say, this project gives 12% return, our target is 10%, we're good. It's simple, interpretable, and it's independent of scale. You can compare projects of different sizes using percentages instead of pesos or dollars or what have you. So going back to our bond problem from lesson 2, this is what it looks like with the price at 1,079. And what is I here? Well, it's 8%, the interest rate used to price the bond in the first place in that example. But let's say you didn't know this. We can work this backward by using the Excel formula, IRR, and then the inputs are an array, and then there's an optional guess value. And this is how it works out using the formula. By the way, you can leave the guess value blank and Excel will seed it automatically on its own. So kindly take a look at this short video. Easy peasy, right? But wait, sometimes there are problems. IRR works beautifully when your cash flows are normal, meaning one initial cash flow followed by inflows. But what if your project has non-normal cash flows? For example, you invest 1,000 now, you get 1,500 at the end of 1 year and 3,000 the year after that. Sure, both inflows. And then you must pay 3,000 the year after that last cash inflow. Now your cash flow signs change twice. That means the NPV equation, which is a polynomial, can have more than one real root. The result might be multiple internal rates of returns. In some cases, the equation might not have any positive real root at all, meaning no valid IRR exists. So lesson 3 about root finding, that suddenly comes to the fore. When you use Excel at times, there might be no answer, or there might be one unique answer, or there might be more than one answer and you won't even know it because Excel will not give an exhaustive list of answers. It'll just give you one answer if there is one. So going back to the previous problem, so these are the cash flows, negative 1,000, 153, negative 3,000. They all sum up to 500, and if you use the IRR function of Excel, this is what it looks like. Now here, this is actually problematic in more ways than one. Here you might think, this is the only answer, and actually that's not the case. There's actually more than one answer here. However, you won't know that on your own unless you test for more than one solution. Okay, so what does negative IRR actually mean over here? To answer the first one, use a 50% guess value, for example, and Excel will give another IRR at 124.1% as shown below. By the way, We're also showing below the present value at a negative IRR for illustration purposes. So this is what it looks like. Here, there is a second answer, which is 124.1% aside from the negative 15.6%. So there are at least two real number answers to this problem. Now, relating to a negative IRR, what does that mean exactly? Well, it means an upside down world. Remember, with a positive IRR, the ratio 1 over 1 plus I, that ratio is less than 1, so it produces a discount, a number lower than the number being discounted. For example, if you're discounting 1, then 1 over 1.1 equals 0.0909. That means an amount now is worth more in the future. An amount 0.909 now is worth 1 in a year's time. So that's what we mean when we say that it's a discount. But what happens with the negative IRR? Then 1 over 1 minus I, where the denominator is smaller than 1, then you're going to have a number 1 over 1 minus I, which is bigger than 1. For example, try 1 over 0.95, for example, which is roughly 1.0526, a number bigger than 1. That means 1.0526 now is just worth 1 in a year's time, meaning your money now is worth less in the future. This can only mean one thing, that your purchasing power now will be even less in the future. In our example, 3,000 in 2 years' time is worth 4,209 right now. This begs the question, why invest if this were the case? So negative IRR does not make any sense at all and becomes simply a mathematical abstraction, a non-starter for investments, unless nominal interest rates in the market are also all negative. But in a world with positive nominal rates, a negative IRR does not make any sense at all. So what should you do when you think IRR misbehaves or you suspect it will act weirdly? Well, here are three options. Option 1, use the NPV profile. Now, what do I mean by that? We will plot the NPV of your projects against different discount rates. The points where it crosses 0 are your possible IRRs. Now choose the one that's relevant to your required return range. Usually the lower one that's positive. And we'll show you how to work this towards the end of the video with a quick video tutorial on how to do this in Excel. Do watch that to generate something like this, where you're going to see what NPV looks like given all sorts of IRRs, and you can chart them so that you can figure out where the zeros are. And here's where lesson 3 comes to the fore and can help you a lot understand why this is useful. Option 2, use the modified internal rate of return, or MIRR. The MIRR assumes that interim cash flows are discounted to times 0 at the firm's financing rate, and all positive cash inflows are reinvested at the reinvestment rate that are accumulated to the end of the period. This gives a unique, realistic rate of return that fixes the multiple IRR issue. You can use MIRR of Excel for this. Alternatively, you can use IRR of two values. The first one, the NPV of all the outflows at time 0, and the second one, the accumulated value of all inflows at the end of the period, and just get the IRR of those two values with zeros in between. Or you can just get the CAGR, or the compounded annual growth rate of those two values, defined by this formula, ending value over beginning value raised to the power 1 over n minus 1. It should all come out the same. Or option 3, rely on NPV. At the end of the day, NPV is king. It measures the actual value added in currency terms, and it's never ambiguous. So here's the key takeaway. IRR tells you the discount rate that makes NPV 0. It's great for intuition, but only when cash flows are normal. If cash flows switch direction more than once, IRR can be misleading, or there could be several answers. In those cases, switch to MIRR or use NPV for a clear decision. So the next time your IRR looks suspicious, don't just trust the number. Ask, are my project's cash flows normal? Because sometimes a single number hides a very complicated story. this helped you understand IRR a little better, hit like, subscribe, and check out our future videos. See you next time!